I'm right with you, Chloe. I have to sleep with cold too. Ours goes down to 58 at night.
Oh, that's a
Yeah.
good plan.
I
I would freeze from hypothermia.
No, has to.
Yeah,
Yours
blankets,
goes down,
right?
yeah. Ours is set at 65 during the day.
Yeah, that's what mine's at. Yeah, 64, 65, somewhere in there. Yeah.
Yeah, can't pay any more than that. My husband works for consumers, but can't get, we get no discount. So
Oh man. Okay. So today is 9/4, but do we have any questions about anything else? Is everyone happy with 9/1 and 9/2 and all that?
finally.
Nice. Okay. Good. Well, don't worry. We're going to do the chapter 9 review today. So we'll circle back to that. And we'll see how well you remember when we shake them all together and mix them up.
I feel like I'm happier with 9/4 than 9/1 and 9/2.
Yeah, that's reasonable, right? Why don't we just highlight all that you need to know for 9/4? It's 3 little formulas.
Right.
Oops, where is it? So, nope. I know where this page is, like 274, right? Hey, lucky me. So this is the reference sheet page 274 that you get to bring to the exam. You can of course rewrite it and whatever. Oh, we didn't highlight this morning. A reminder of Q, a reminder about the margin of error. E must be a decimal for proportions, all of that. Maybe the unfortunate thing is that this page also contains the chapter 11 formulas that look really intimidating, but they're really not. Well, this one looks rough, but it's really not that terrible. So essentially your job tonight is to decide which one of these 3 do we need to use to calculate. And I'm going to suggest, I'm going to begin what I think is a good thought pattern to practice as you encounter any problem from chapters really 8 through 11. And that is that the first thing you should ask yourself is what parameter are we working with? That's a key point, because that determines which of any of the other things you would use. So there are only 2 that we work with in this class. It's the mean. Good. Labeled as mu. That's the parameter. Remember, the statistic is X bar, which is the point estimate if it's a confidence interval. And then the other parameter, which was kind of new for chapter 9, we talked about means a lot back in chapters 3 and etc., is proportion, or p hat. I guess I should have mentioned that often what comes with a mean is a standard deviation. Proportions are almost always percents. So maybe I'll put a little s, comma, sigma in here as reminders. You'll see those in the problem. So a big portion of the final exam is reading through the question and deciding, is the question dealing with a mean or is it dealing with a proportion? The second thing, really what's going to happen, the second thing is going to be, is it a single sample or double sample? Well, we'll talk about that after chapter 11. So we'll ignore that for now. The second thing is, what's the question? Like that, I mean, this probably goes without saying that you should figure out what you're being asked before you try to answer the question. But it's nice to think this way because there are really like 3 or 4 main classes of questions. There's the verify question. Verify the conditions. And remember, the first 2 are exactly the same for mean and proportion. It's just condition 3 that you got to keep track of it being different.
Right.
Let's see, verify conditions. There is the construct the confidence interval. I'll just put CI. which isn't, I guess neither of these are actually questions, they're statements, but whatever. There is a, man, I feel like I had 4 of these this morning. There was the how many question. Dot, 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 which is the one, this is the 9-4. So
Right.
really, if we were to put these in the order that they occurred in the notes, this is chapter 8. This is 9-1 and 9-2. And this one's the 9-4. And then we shake them all up and toss them at you.
And switch the words around to try to
Yeah.
trick us.
Yeah. I mean, that seems fair, doesn't it?
No.
We try to tell you all the ways we try to trick you, I think. I think there's one more. When it comes to me, I'll come back to this. So after you know the question, it's then, all right, what do I need to use? So here I just would put reference material, because you don't need to have anything memorized. It's, hey, if you recognize it's a verify, go to the chapter 8 or the confidence interval stuff and look at the 3 conditions. If it's a construct the CI, go to the confidence interval position for proportion or mean. If it's the how many, go to the sample size formulas. And then finally, it's, stat crunch it, get the answer. This often involves stat crunch. But maybe I should break this one down, and that would be identify what you know.
Mhm.
Everything's there that you need. And then either write the answer or stat crunch. Sometimes we give you the stat crunch output. Run the formula, maybe. Maybe I should do stat crunch / Desmos, because sometimes you just need a calculator. Ooh, what's going on there? And really, that's all there is for the next 3 chapters. Is it a mean and proportion? What's the question? We're going to add one more to this. It's called the hypothesis test. That's chapter 10. You will be intimidated when you first read it. By the end, it'll be so easy you won't even worry about it. Okay, so let's do this. Let's follow this pattern. We'll see if it's helpful. If it's not, it's not, and that's totally fine. I won't cry too much. With the chapter 9 worksheet, let's go to page 666. So this is the 033 worksheet. This one, we kind of ease you into it. We like what's going to happen in the next worksheet is we'll just say, here's the thing, find the sample size. How many? Like we'll just ask you C. But this question's nice because it eases you into the different pieces that you need. So first, let's identify what parameter is happening in question 1. A researcher wants to construct a confidence interval for the mean weight loss. Wait, did I say the answer?
You did.
Mean weight loss.
Mean.
Nailed it. So we can use the symbol, we can write the word. This is a mean question. Assume the population standard deviation is 7 pounds. Okay, nice. We'll put that there. Question A, if the researcher wants to construct a confidence interval, which formula will she need to use to determine the minimum sample size? Tricky. What is the question you're being asked to answer?
What is the sample size?
Okay. Now, actually, it's simpler than that. It's what formula do you need to use to calculate the sample size? But you're right. This is the important part. What's the sample size? I can't tell you how many times I have graded an exam where someone does this. They construct a confidence interval. And I get it, right? Because it says construct a confidence interval. If you're scanning fast and you see that, and then you just get into your fear gears going and you just start constructing confidence intervals. You can do it with the information that's here, almost, not quite. But no, this is find the sample size. Okay, so you can find that on your page here, the correct one, right? Oh, there's only one. There it is. Hooray. Look at question B. What are you being asked there?
What's the critical value?
Okay, well, what is a critical value? Maybe more importantly, which thing in the formula is the critical value?
Stat crunch.
Yeah, right. That's the correct answer. Yes, that's right. It's this thing. Now, if you're forgetting how to find Z alpha divided by 2 in StatCrunch, I got a page for you. 271. Did it in chapter 7. Maybe I should have added this to the list of questions you might be asked. What's the critical value? Okay, I think you've got it. Do number 1. If you get stuck calling us, let me give you 5 minutes. See if you can't get all the way to E, but that's kind of a lot. But let's see. Set a timer for 5 minutes. I need to say for the record, since we're recording, this is ginger beer. It's non-alcoholic, and it is sweetened with honey and pineapple. And it was on sale at Meijer. It was clearance. That's why I bought it. Just for the record, for those of you that watch the videos, it's really good. Cheers. Okay, that was 5 minutes. I'm assuming we all agreed on this part, right?
Mhm.
Except for the N part. I don't know where N came from. Should be E. Okay. What'd y'all get for the critical value? Anyone have-
1.96.
Nice. Anyone else have that memorized?
I got it all written down.
Oh, you got them. You got all the ones. Yeah. I'll just show you this. They're also right here. So here's this table, and this is the area. The problem is it's alpha here, and not the way we've done it is between, but here's that 1.96. So they're there. Don't worry about it. You got StatCrunch, but if you want to figure out how to use this table, let me know and I can help you. Maybe that's faster. So what'd you get for your answer? School shooting, geez. Did you do? Well, what'd y'all have for standard deviation?
.15.
That,
Oh, that's a margin of error.
no worries.
Oh, 7.
So, yeah, 7. This one's a little tricky, right? Because it said population standard deviation is 7, and our formula wants us to use the sample standard deviation. It turns out the population standard deviation, nice, LaShawn, is always the best number to use. We just almost never know it. In this case, for whatever reason, we know that that's what it is. So apparently the population standard deviation for weight loss is 7 pounds. Okay, so I'll just smash this in Desmos. 7 times 1.9, oops, 96. All that divided by, maybe you won't like that, 1.5. That was the margin of error. And then one thing that students often forget is the squared. Easy thing to do. So 83.666. Now, standard rounding rules say we should round this to 84. Our job is to always round up. It states that right here, round up. So it doesn't matter what the decimal is at the end. You're always just going to add 1 to the whole number. If it was 0.024, you would round this to 84, always and forever. So this is 84 adults. Is everyone happy? Okay, did you all do D? Pick a higher C level. Now I should really open up StatCrunch, shouldn't I? And see what happens. So you were over here in calculators and normal, and we were between, it was 0.95. So what's a nice higher critical value or a C level? 0.98 maybe. So where does this 2.326 go?
It replaces the 1.96.
Nice. So what happens when we do that? Look at the sample size. It went up. Now I know in your notes you've got some things, right? I don't know if you did the symbolic. I often write these like this. If you increase the C level, So if you
Sample
want to
size
be,
goes up.
that's it. That's what this is highlighting. It's just doing a numerical computation to show that when you increase the sea level, the sample size has to increase. I think there's some logical kind of like common sense maybe types of thoughts here. Like if you want to be more confident about your results, just talk to more people. As long as it's random and independent and the sample size is normal, the closer your sample size gets to the population size, the more accurate results are going to be. But this is just showing computationally how the connection between the confidence level and the N. Note what happens. Increasing the sea level gives you more area under the curve, which is going to make your critical values larger.
Mhm.
Since the critical value is in the numerator or the top of the fraction, the number itself is going to get larger. All right, what happens if we have a smaller margin of error? We're going to change this 1.5. In other words, finish this sentence. Decrease E, what happens to the sample size? Well, let's change 1.5 to 0.75. Ooh,
Goes up.
goes up quite drastically. That should make sense too, because the margin of error is what we divide by. If we have a smaller margin of error, we're dividing by a smaller number. That's going to cause us to have, that's going to make the sample size become larger. Shoop. Another kind of common sense way to think about that is if we want to narrow the scope of our possibilities, if we want to make the possible values for the parameter in a tighter grouping, that's what margin of error does. It brings the confidence interval closer together. Then we have to have sample sizes that are closer to the population size. We have to have more accurate sampling. Okay, this is a great question. Why do we always round up? Like this one, it was appropriate to rounding caused us to add one anyway, so that was correct rounding. But even if we had 123.0271, we would round this to 124. Why? Any good guesses? I'll talk you through it. How about that? Or should I wait you out? No, I'm going to talk you through it. So what we're doing here is we're calculating the minimum sample size. We're like being as efficient as possible and as cheap as possible. We want to talk to the least amount of people as possible, but we aren't going to lower our standards. We want to be 95% confident that the parameter is in this confidence interval, and we want to be within this margin of error. So we've got a strict requirements on what the results we want to get. And so when we run this, we're trying to get the smallest, most efficient amount. If we did 83, like this one was 83.666. If we talked to 83 people, we would be one person shy of meeting these two requirements. And we couldn't guarantee a 95% chance of the parameter being in there. So it is to ensure that our standards are met. If we talk to more people, we're just going to be more accurate, right? Like we could talk to 1,000 people, great. We'll definitely hit the 95 and this margin of error. But if we want to talk to the smallest amount, it has to be at least 123.0271. And since this is part of a thing, and you can't have part of a person or a thing, we round it to 124 to guarantee the results. So you want to know what to write. Just summarize what I said. It's cool. I don't mind. Welcome, Alexa. No worries.
Oh,
Where, oh, I should
So
tell you
say
where.
that again, Eric, what, for number 2, what is the answer?
Yeah, so we are finding the smallest sample size that guarantees the C level, the chosen confidence level and margin of error. And since you can't have part, you got to add one. Cindy, help me make it better.
Yeah, no, I think, Nicole, we did talk about this, and basically I said it real easy, simple, and just said, so that it will be large enough. So if it's 123.02, 123 would not be large enough. So you have to round it up to 124 that it would be large enough.
That's much better.
No,
Yes.
you were good. It
Well,
was just,
I mean, it's mine is like a lot, like it's a lot of extra. That's good. Yes, that cuts right to the heart of it.
that's why you have your master's and mine's in elementary ed.
Fair, fair. Sure. Okay. We good? Is everyone good?
Can you go, I'm sorry, my brain's not working today. Can you go over the calculation for like C? Like how would I plug that into the calculator?
Here's how I typed it in. So one thing that could help, because it's a fraction, I could zoom in too. Shoop. One thing you can do is hit the division button. So you have a nice fraction in there to start with. And I needed 7 times 1.96. This is the one where I changed the 2 different numbers. And
Right.
we're dividing by the 1.5. And then when I just do the parentheses, when I put one of them in, it automatically puts the whole fraction in there. And we're going to square that. That's Desmos. I love Desmos. If you're going to do like one of these little calculators, let's see, I would do 7 and then times 1.96. I would equal that, 13.72. I would divide by 1.5. I would hit enter to get that number. And then I would square that and you get the same thing.
Okay.
Your
Thank you.
TI-84 that you're using, your color version there, which is a nice, you know, that's like a 2000s machine. That it'll do fractions in there. I forget where the button is, but there's a button that will make this happen if you want. Really, all you need is parentheses around this. So
Yeah,
that,
Sarah, I was gonna say, you can use your parentheses there and pretty much
Mhm.
do what Eric did. And just use your division sign to divide that and then square it.
So
Yeah.
I can put the parentheses and put it all in.
Yep,
yes,
Okay.
and then square it.
Okay.
outside of it. Yep, that's the key. Because inside this is going to do it right no matter what, because there's no order of operations to be worried about.
Okay.
It's the squared part that can mess it up. Cool. Okay. So question 3 on page 667 steps you out a little more. This is more like what you're going to encounter on the final exam. Just do it, right? So I'll be quiet for 5 minutes and see how you do. Try to find what parameter is it, what's the question you're being asked, and what formula do you need, and then do it. Set a timer for 5 minutes. Okay, that was more than 5 minutes. Y'all good? What parameter?
Proportion,
Ooh, how do we know?
it says it.
So this is often the worst one where it doesn't say it, but it did, right? So nailed it. Okay, what's the question? How many?
Mhm.
Now, if we could keep reading, or we could note that for the how many, which is the sample size, there are two formulas. One where we have a p hat, a prior estimate. We know a percentage already, and one where we don't know a percent. Which one is this?
Without.
Good, because there isn't a percentage there. Oh wait, but there are two percentages here. Are we sure it's without?
Yes.
Yeah, right, because this is the C level. So this is going to tell us what the Z alpha is. This is the margin of error. Now, the one thing that most students get wrong in this is the margin of error. They forget to convert it to a decimal. Did you put it in as 0.05 for E?
Yes.
And 1.645 was your Z alpha, right? When you put in 90%? Anyone need to?
I didn't round, but yes.
Okay, you did 1.6449 or something?
Yes.
Okay, this is highly sensitive to rounding. Your answer will be fine. It will be a little different than mine because of the 0.5 being squared. Yours might be a little bit smaller, but let's see, maybe not. By the way, anyone know where the 0.25 comes from? Why is it 0.25?
Okay.
So if you look at the formula, we have like a p hat times a q hat, which those add together to equal 100%, always. Well, the largest multiplication of two numbers between 0 and 1 is 50-50, 0.5 times 0.5. So the assumption is that the proportion is exactly equal if we have no prior estimate, and that gets us the largest number here, 0.25. Otherwise, we get some other p hat times q hat, and that number is going to be a little bit smaller than 0.25 on a scale based on how far apart these are. So if you're wondering why, it doesn't particularly matter. It just is what it is. So we said 1.645 divided by 0.025, or was it 0.05?
0.05.
Yeah, there we go, 0.05. Excellent. And then square that and you get some sort of answer. 271?
Yes.
Good. Okay. So 271 freshmen. How is B different? What is this 38%?
P hat.
P hat. So now we do 0.38 times 0.62. Everyone know where I got the 0.62 from? 1 minus P hat equals Q hat. Notice, well, actually, you all tell me, what's the answer? What's the final correct answer for B? Nice, y'all. 255, 279, 84, 26, random numbers, E, pi. It's 256. Does everyone agree?
Mhm.
Notice I rounded up. This one might cause you some pain because you're like, it's a 0 after the 5. No, the answer is 255. But remember, this is the minimum amount we need to talk to is this. Oh, let's see, if we do 1.6, good point, 49, it makes it 255. Yeah, nice. So here is a really important point.
Show your work.
Show your work. It didn't say here what to round critical Z values to. Sometimes we say round your critical value to 3 decimal places, which if you remember, that's kind of what we've been doing all the time. But you're not wrong if you do 4.9. So yes, show your work. Otherwise, if I'm grading quickly and not paying close attention or really thinking and I see a 255 and wrong, that's your only answer. But 255 is actually the more correct answer because of the less rounded value here. Good. Okay. How about we put in order from narrowest to widest based on the sea level? So what do we know about the sea level and the width of a confidence interval? So let's see. Here we can talk about it kind of just conceptually. If we want to be super confident, we cast a really wide net. I think I started this with saying I'm 100% confident that the mean score on the final exam will be between 0 and 100. And I've just listed all of the possible numbers that we could get for a mean. Yes, I've said nothing, but I can be 100% confident about knowing nothing, right? Like that's great. So as we make the confidence interval narrower and narrower, so we give less and less possibilities, our sea level will have to be lower and lower. So the widest confidence interval will correspond to the highest sea level, and the narrowest confidence interval will correspond to the lowest sea level. So what, 65% from narrowest to widest, then 75%, then 85%, then 95%. So you can think like narrow, wider, wider, widest. Although that's probably not helpful. It's more confusing visually than not. I should calm down for a second. I'm going to ask a completely random question. Just probably doesn't have anything to do with anything. What's a point estimate and where is it in the confidence interval?
Center.
Ooh, center, yes. What is it?
P hat.
Or,
X bar.
okay, so the point estimate is the statistic, which for our class is either p hat or x bar, meaning sample proportion, or sample mean, and it's the exact center. Oh, look, here is a sample mean of 100. Which of these confidence intervals, all of them, none of them, could be an interval for that mean? So what does the center of each of these intervals have to be?
Has to be 100.
Good. Now, while you're thinking about that, did you remember the formula? Nailed it, y'all. Or maybe y'all don't need to know this. Did you remember that you could calculate the point estimate from the confidence interval by using this formula? Go. 2 minutes. Set a timer for 2 minutes. Okay, that was 2 minutes. How about the first one? Is 100 in the middle?
No.
Right. It's 80 plus 110 is 190 divided by 2 is not 100. How about the second one?
Yes.
Yes.
Yeah, that's equal to 200. Next one is also 190, so no. Just a quick reminder of that connection between the upper and lower limit in the middle. It doesn't matter whether it's a mean or a proportion. When we add them together and divide by 2, we've got to get the sample value. Okay, a nice true or false question. If you take large random samples over and over again from the same population and make 95% confidence intervals for the population proportion, about 95% of the intervals should contain the sample proportion, true or false.
Not sure about this one.
It's a tricky one.
Oh,
Where, when we create our confidence intervals, where are the point estimates? Every single time, where are they? Yes, LaShawn, the exact middle. Every single time. Wait a minute, what's a sample proportion? Is it an X bar? Is it a p hat? Is it a point estimate? Is it a scribbly scrap? No clue? So it's the same question you answered, y'all answered back up here. The point estimate is the exact
Okay.
center.
never.
Yeah, and it's either a p hat or an X bar, meaning sample proportion or sample mean. So 100% of these confidence intervals will have the sample proportion, and that proportion will be the exact center every single time. We made it that way. We are constructing it that way. And provided the 3 conditions of the central limit are met, it's an accurate construction. Like there's nothing wrong with it. So this is false. They're all going to be there. 100% of the p hats will be in the middle. We can even say exactly where it is, in the middle of the CI. Now, I could change one word in this, and I could make it true. If I changed it from sample proportion to population proportion, that's exactly what the C level states. That's precisely the theory that we're using here. We picked the C level to say what percentage of our sample confidence intervals will contain the population value, which goes to B. Notice that says, hey, if we're using a 96% confidence interval, 4% of those will not have the population parameter. Totally true. That's exactly what the theory says. There's a 4% chance the one confidence interval we create doesn't have the correct value in it. There's a 96% chance it does. We like those odds, so we go with it. How y'all doing? I know everyone loves the theory stuff. True. Okay, so let's go back to some of the computational things. I want to see how things are going for you. Let's go then to the 9-4 worksheet. We probably won't do every single question, but we'll do a bunch of them and at least talk about them, because I also want to spend some time on the chapter 9 review. So try number 1. Remember, figure out the parameter, determine the question, find the formula, do the substitution, get the results. 5 minutes. You've kind of already done this problem. Set a timer for 5 minutes. Oh, sorry, I didn't realize I had my speaker on. Okay. Parameter. Did everyone find that word? Does everyone need more time? Sea level. E.
Mhm,
No prior estimate.
mhm.
So 0.25. Let's see. When 90% is 1.6449 or 1.645. I think I'm going to stick with 1.645 because that's most common for my stat lab. And whatever that is should be your answer. Next one is the same question. Everything's the same except, oh, we already know that 43% of Americans believe demons are real, which is what this is about. So we're going to use the with a prior estimate. So there's your P hat. Here's your Q hat. And multiply away, and you got your answer. Everyone good? Are we going too fast, or is this it's about right? Yay for doing it right. So what happens when you raise the margin of error? What happens to n? If I make this number bigger,
Sample goes down.
that's it. The larger the number is you divide by, the smaller the result will be. So it gets smaller. Okay, I'm going to let you all do number 2. How about you try number 3? 5 minutes, see if you can't get it. Start to finish. Set a timer for 5 minutes. And then I might need some feedback from you all. Like, are we going okay? I mean, I'll let you work and then I'll ask it.
Hmm.
Okay, that was 5 minutes. Was that a mean or a proportion?
To me,
How'd you know?
because it says average.
There you go. This one's a little tricky, but it does say average. The other clue, standard deviation. We don't need standard deviation for proportions. The other clue is that your margin of error is not a percentage. So you shouldn't be converting that to anything. Anyone get the result? So I'll have to type it in here. Well, let's see. Standard deviation of 2.8. So it's going to be something like 2.8 times 2.5 something something. Anyone got the Z-score for me?
2.5758.
5758. Thank you. And
Is
then
the
that-
answer really like 37,000 or 370,000?
I get 37.
Mhm.
Okay, cool.
Did you change the 1.2 to 0.012?
I did.
That'll do it. So that's the difference between the mean and the standard deviation. I mean, the mean and the proportion. One of them, you're going to convert the percentage to the decimal. The other one's just straight units. One of the things to remember when working with the mean is condition 3. It says we need a sample size of at least 30 to use the central limit theorem, or the population itself is normal. So this population was normally distributed. We probably won't be too far away from 30. Now that's not always true. Let's see, we have a pretty high confidence level. So I bet if we drop this, we might get less than 30. That's possible. It can be done with means. So 37 is the answer I get. Let's see, if you rounded to 3 decimal places on the critical value, you'd still have 37. So in this case, it doesn't particularly matter one way or the other.
Where does the 2.8 come from?
Great question. It said that it has a standard deviation. We know this from previous studies of 2.8. So if you look at your formula for means, you need the S, which is the sample standard deviation, and you need the Z critical value, and you need the E.
Lord.
Those 3 things. Is that making sense? S is here. Margin of error here. Use this to get the critical Z value. And I didn't type it in, but we could. 0.99 for the between gives us 2.5758. Questions, concerns? Get where? Because you can't get to here in StatCrunch. So can you be more specific, Alexa? What place are you trying to get to in StatCrunch? Oh, to get to the normal calculator, you go to Stat, Calculators, and Normal. And that's for calculating Z critical values. If you need T critical values, you go to the T calculator. But we only worry about T critical values when we're constructing the confidence interval. When we're working with the sample size, we always use Z critical values because we always have an estimate for the sample standard deviation. So we don't need a critical T value. Does that help, Alexa? Okay,
Can
good.
you go back
good.
to the formula, Eric, that
Yeah, here.
the one that you wrote for this question?
Oh, I didn't write one.
Oh, I thought
You mean this? I'm sorry.
yeah,
The calculator.
sorry, it wasn't, yeah.
You're good. You're good. Here, this is maybe the way I typically write it so that it looks the same way it does in the formula. So how are we doing?
Well, I am still struggling with using the right formulas.
Which one did you use?
But I used the opposite one. So I see what I did. I'm just struggling to start
Like,
off using the right formula.
Gotcha. That's why I say, here's what's in my head. Figure out what is it that we're working with, mean or proportion.
Mhm.
It said mean. Here's the mean one. Ignore everything else. There's your formula. If it said proportion, here's proportion. Now we have to pick between these two. So then you have to look, is there a prior estimate or is there not? So in my mind, what drives the formula you pick is understanding which parameter is it that you use, and then you're just matching the name of the parameter on the reference sheet to the one you found in the problem. I found that this was mean, so I'm looking for the reference sheet material that talks about the mean. Is that helpful or not so much?
It does, but I don't know why I'm struggling to pull it out initially. I'm not sure why, but I'm just, I
Nicole,
mean, it says it right there, so I know it should be simple, but for some reason it's.
Well,
Nicole,
average
look at
doesn't
Struggling
sound
with
like
it too
mean.
tonight.
Go ahead, Sarah, say it.
I'm struggling with it too tonight.
That's okay. It's okay, y'all.
I'll
That's
tell you
why
what's been helping me is the flow chart that we did on Thursday. So when you said to pick the parameter, that was huge for me because once I find out which one it is, I just look at the flow chart and pick it.
Patty, can you remind me of the flow chart page?
224.
And I think and I'm trying to look back at all of those things, but for some reason that I don't know why I wasn't going to that one. I was looking at the other, I don't know why I'm looking at the wrong data, but I was looking at the confidence interval flow chart.
Oh,
Yeah.
oh, well, you know
And then
what?
just
That
getting confused and then just trying to combine,
gotcha.
I don't know why I'm struggling with it. I just am.
I think I know why. It's not like you're not crazy. Let me say that. It says right here, 99% confidence interval. So the words are literally in there. In fact, sometimes it's even worse. Sometimes we're like, how many people do we need to talk to so that we can construct a confidence interval? And it does say how many, but then it just says to construct, right? Like right here, estimate how many people need to be surveyed is available and the researcher wants to be, never mind. I guess it doesn't say confidence interval. I feel like sometimes it says it. I mean, this problem did. It had the phrase that cues us in to look at that other formula.
Yeah, that
so
might be why.
So it's just keeping track of where is the question. What is it? And here the question is how many? That's the key we should focus in on, not the confidence interval language over here. All we needed from this was that it's a 99%. Okay. Those are the big questions. Then it's like, hey, let's lower the sea level. What's it gonna do? Lower the standard deviation. What's that gonna do? That kind of stuff. I'll let you kind of think on those. And let's go to Chapter 9 review. If we have time, we can circle back to those. Or we can talk about them on Wednesday or Monday. So let's go to the Chapter 9 review. And now I'm going to shake it all together to really test you. Because so now back here, we weren't going to ask you to do a confidence interval, construct one, because 9.4 isn't about constructing confidence intervals, right? It was about calculating sample size and the connection between the confidence level and the sample size and the margin of error and the standard deviation and all that. If we raise them and lower them, what happens? Now we're just like, okay, you know Chapter 9 now. Yay, aren't you excited? Let's see if you do. So if I go back to this worksheet and add the one other question that goes under what are the questions you're asked, it would be to say, find the critical value. That's the one other one that happens in here. And there are two possible critical values, a T critical or a Z critical. T's go with means unless you're calculating sample size. Z's go with proportions and sample sizes. So I think Patty is probably got a great idea, and that is to maybe use this flow charts. And there are two of them, right? There's one to flow with the confidence intervals. There's the other to flow with the sample size. So maybe if you're using this, it might be more helpful to figure out what's the question first, then what's the parameter, because the question determines whether you should be looking at the confidence interval flow chart or the sample size flow chart. Remember, sample size is it's right here. How many or what sample size, or estimate. And then the confidence interval is almost always a command. Construct this. Sounds very powerful. So if we flip the order, then you pick the correct flow chart. Then you pick the correct parameter. It's probably like mu or whichever. And then your formula is right in the box, which is probably a lot easier to pick from than the ending reference sheets at the end of the page where they're kind of all over the place. So maybe try that. So let's skip the critical value one. This is just, can you smash it in StatCrunch? Go back to Chapter 7 if you need help with that. And let's start with number 3. I'll put on the clock 5 minutes. You see, can you figure out what the question is and what the parameter is? And if you can get those two things together, I think you can get the formula. But let's see, try it. Set a timer, 5 minutes. All right. Anyone know the question?
How many?
Good. So it's a long slog of stuff to read through, right? But here's the question mark. And we go back to the sentence and we find it's how many fish. Good. What's the parameter?
Average, mean.
Good. We're figuring out the mean. So we've got standard deviation. That's a necessary thing. We've got margin of error of this 0.27 pounds, and we've got 90% confidence interval. That's all that you need to answer this question. So let me write this down and you check yourself. I know the formula for calculating the how many of a mean is this, the sample size is equal to sample standard deviation times Z alpha divided by 2 divided by the margin of error, all of that squared. And so I know a 90% confident, well, let's see. I know the standard deviation is 3.92. I'm going to multiply that by 1.644. Nope, let's go with 3. So I'm consistent. 1.645. How do I know that? I just happen to have this memorized because we've used it a couple times tonight. What you would do is go to your between calculator and StatCrunch and type in your 0.90. And there is your 1.6449. So we're going to smash that in there. And then we're going to divide by an unchanged error, margin of error. We don't do anything with this 0.27 because this is a mean. So these are an actual amount of units that we're using. It's proportions that we divide by 100 to convert the percent to a decimal. So this is what you should have. Anyone have that answer? So I don't have to type it in.
570.32, whatever. How about you, Sarah?
That's what I got too.
So rounded 571.
571 fish.
Mhm.
Okay, so remember how before I said it could be close to 30? Well, here we need a ton more, but we have this margin of error is really, really small. 0.27. Like when you're dividing candy among kids and you're breaking each piece of candy into fourths, you got a lot of candy to give out, right? They're tiny pieces, but there's lots of them. So that's what's happening there. Awesome, Will. I love it. I think it can be useful. Yes. At least it's a nice way to separate the information, the sets of things you need. You are welcome to use all of the flow charts on the final exam. There are going to be 7 of them, I think, or somewhere 5 to 7 of them, because there'll be like 3 for chapter 10. Although you might not need them as much in chapter 10. I don't know. Okay, I'm going to switch to another question on here. I'm just going to lead you around. So I would like you to do the question on page 674. All right, so I'm going to give you 5 minutes. That's probably not enough time, but we'll check in and see how far you've gotten on page 674. Set a timer for 5 minutes. Okay, did I catch you off guard?
For this question, is that what you're?
Yeah, so like what was this one asking you to do?
Verify.
Verify. Yeah.
Verify. So your sheets might not be as helpful this time around, right? Your flow chart for A, where are they? Does A have a verify section on it? It doesn't, right? Was there a chapter 8 flow chart? I don't think so. So you've got to remember that when verifying, you're looking at, you can look at one of these two. You can go back to this page 272 and here's the verifies. Or maybe you add a section of verifying on your flow chart. That's helpful. Now we're verifying, but for what parameter? Mean or proportion?
Proportion, it's a percentage.
Portion.
Good. Good. Okay. So you did random given sample size of 2238 is less than or equal to 5% of 210 million. Check, right? And you did n times p hat times q hat is greater than or equal to 10, right?
Oh, I didn't do that part.
Mhm.
So don't forget that one. C3, that's the one that's different. That's the one I look for the most.
I did it, just not for a proportion.
Gotcha. You did
Me-
it for a mean. Yeah,
I did
that's
too,
why I
Sarah.
look for it. Yeah. So easy to mess that up. By the way, here's another clue.
Mm.
We're working with a proportion. Did anyone go on to B?
I'm working on it.
I'm working on
Okay.
it.
Let me give you 5 more minutes and you keep going on B and C and D and E. So down to 5 minutes. Your flow chart might start helping now when it says construct, right? Because that's, you have a flow chart for constructing.
into that.
Okay, maybe I didn't unmute. That was 5 more minutes. How's everyone doing? Anyone know the formula for constructing a 95% confidence interval? Did you have that on your thing? P hat plus or minus Z alpha divided by 2 times the square root of the angry face. You recognized P hat here. And we're able to calculate Q hat from that. The question is, were you able to type this into StatCrunch? So one of the things you need is that X is equal to P hat times N. Did you all remember to do that? I bet that's on the flow chart. Oh, requirement for normal. Oh yeah. Well, this is condition 3. This is condition 3. Look, here's the interpretation. Oh, that's wonderful. Look at all these things on here. So I guess the one thing it's not giving us is how to find X. So whichever one of these made the normal, you should include that little formula there, that X is P hat times N. I mean, a lot of students are just like, oh, I get it. It's 57% of the sample size because you're comfortable with percentages. If you're not, no worries. Make sure you do that. Did you know where to go in StatCrunch once you found all those things? Like this tells you right where to go. Stat, proportion stats, one sample with summary. Remember I told you all to write down that X is the same thing as number of successes. That was 1276. Observations 2238. This is a confidence interval. We want 95% confident in our result. We want to show the critical value and compute. And here's your lower limit and upper limit. Is that what you all had? Must have been an exciting weekend, huh?
I got everything but knowing how to find X. So that was helpful.
Oh, good. Like you can't get StatCrunch to give you this stuff without that.
Mm-hmm.
Without that X. You're stuck.
Yeah.
You can calculate it, manually calculate it. I strongly discourage that. Just because it's complicated.
It's an ugly number.
Yeah. Chord number. That's how it was born. Why do we gotta call it that way? It's got its own, it's got inner beauty. How do we feel about that?
Mhm.
Mm.
Okay, interpret.
So
oh, it's-
that would be our result.
That's the result. This is the thing we wanted all along. All the other stuff is just to make sure you know what you're doing. So I think the way you've been writing this is you've been putting the numbers right in here. So 0.57 plus or minus 1.96 square root 0.57 times 0.43 all over 2238. Like this is probably what's on your sheet, right?
Mhm.
So I'm so confused. Where does X come in? What am I
Hmm.
missing with X?
So did you get the lower limit and upper limit?
No, I didn't even get
We
that
need
far.
X
I
to
had,
be able to get the lower and upper limit.
Yeah, we need
What's
X
that?
to go to use StatCrunch.
So go to StatCrunch and
oh,
do
because
your,
we needed that for the number of successes.
Success.
Okay,
yeah, that's the only thing we
Okay.
need it for. We
I
don't
had the-
actually,
okay. So I had the formula there, but I did forget to do X.
And that's where I stopped with it too, is because I had the formula, but I also forgot to find X. And then I didn't have wrote down what the success and observation was either. So it's wrote down now.
you got it. Yay. Okay. Okay. I mean, like you can manually enter this, type this in Desmos, and you can get the lower limit, and then you can do it again, one of them with plus, one of them with minus, and you can get it. It just, to me, feels like a lot more work, and there's a lot more places you could accidentally type something wrong and not get the result. I kind of remember everyone being good at interpreting. Are you all, or am I wrong? I mean, after seeing page 225, nope, 224, nope, 223, there's the sentence right there. All you have to do is insert the context for what the parameter is. We are blank confident that the true population proportion of US adults who say medical doctors care about the best interests of their patients all or most of the time is between 54.96% and 59.07%. You don't need to write every single one of these words. You could just say doctors who care. Let's just say that. So that's just basically copy and pasting this and replacing the word parameter with what it is. Also putting in the numbers for these. Ooh, anyone know the point estimate?
0.57.
It's the p hat. Am I starting to sound like a broken record with that point estimate thing? P hat or X bar. It's the sample value, the sample statistic. Compute the margin of error for the interval. Oh boy, do you remember that formula?
Plus.
This is one way you could get it. The minus, because we're going to say how far apart are the numbers for the interval, and we're going to cut in half, and that's going to be the distance between the p hat and the either limits. You could also subtract p hat from the upper limit and you'd get the same thing. Wait, is the margin of error given to us in StatCrunch? No. It's the standard error. That's a whole different thing. However, if you recall, the margin of error is also the standard error times the critical Z value. So you could multiply these together if you're not a fan of subtraction and division.
That's true.
So it's either formula. It doesn't matter to us how you get it, just as long as you know ways to get it. Okay, we've got 5 minutes left. I want you to notice number 9, that it's the same question. Verify, construct, interpret, test a claim. Question is, what parameter? When you glance at number 9, what parameter are you being asked to work with?
A mean.
Mean.
Good. Word average gives it away. The units on the numbers give it away.
Standard
And then
deviation.
And the standard deviation gives it away. And then the most obvious is we literally say use for mu. And we're assuming. Go ahead.
Yeah, that's fine.
All right, let's skip back a question. Look at number 4 on page 673. What is the question and what is the parameter for number 4?
How many and a proportion?
Good. Estimate how many? Here is the word proportion. So the thing to remind, the thing to take comfort in is that everything you need to answer the question is within your fingertips.
Mhm.
We give you everything you need on the page to
Mhm.
direct you to the reference sheet for the formulas and the pieces. You smash it all together, you mash some numbers, and out comes the result, right? So it's all here. You just got to get comfortable with the 2 different directions you're going, proportion or mean, verify or construct, or how many, or calculate a critical value. I'm going to leave this for you all to finish. This might feel really frustrating because there's lots of blanks on here, and that's kind of on purpose. Check back on your 9.1, 9.2, and 9.3 and 9.4 worksheets. Is that really how many we did? No, 9.1, 9.2, and 9.4, because you've already done all of these problems, every single one of these, except for maybe these 2. We just did this one. Find X, given a P hat and an N. Find P hat and Q hat given an, well, we haven't done this one. Let me just remind you that P hat is equal to X divided by N. You did actually do one of these back in the 9.1 worksheet. So you've done all of these. Try them, and Wednesday and or Monday, I will be happy to go over them again. The good news is there's only one more concept you have to learn, and that's hypothesis testing. And then there's nothing else that's new structurally. Chapter 11 is a repeat of confidence intervals, but we're doing 2 samples instead of 1.
I can
And then
hardly wait.
Yeah, right. So yeah. So it is a big jumble, because it will be, are we doing a confidence interval? Are we doing a sample size? Or are we doing a hypothesis test? Is it a mean or a proportion? Is it 1 sample or 2 samples? So it will just be this big old long list of things, but you'll have your guidebook that says, oh, if it's a mean, go here. If it's 2 sample, go here. If it's 1 sample, go here. If the question is this, do this. And it's there. And don't be frustrated if you don't have it all yet. You're going to get it. Just takes a little time, a little practice. Okay, any questions for me before you all go and sleep under the covers of your 49-degree house temperatures and dream of Christmas, I guess? I don't know. What do we dream of these days? Or the Bahamas, and then we'll hit it again tomorrow and Wednesday. Sounds good, everyone. Sleep good.
Night, Alexa. Night, Hope.
I don't know that.
Oh,
Yes.
my Alexa came on again, Alexa. She was telling me that they had to change the name of all their Alexas in their house.
Oh, I bet. Yeah.
So Eric, just so you know, like you letting us know how to decipher what the parameter was huge for me.
Good.
Huge.
Good.
You know, you read it and it's like deers in a headlight. And so it's like, now it's like, I just pick out everything, look at my thing, do the formula. Super happy.
Good. And that is really, to me, that is the hardest part that students struggle with. It's just this smorgasbord of things to go through. But if you can narrow it down to the piece you got to get, that
Yeah.
directs your way. And you
For
can
sure.
find it out.
Very cool. Thank you so much.
You're welcome. Great work.
All right.
Rest
good
of the
night.
Tomorrow,
district-
guys.
See you tomorrow.
Yeah, you'll get it, the rest of you.
Cindy, I won't be here tomorrow.
Okay,
Okay, but I'll be watching the video.
all right.
See ya.
I
Have a good night.
You too, Sarah.
Oh, I do have a quick question.
Yes.
Yes.
Can we talk grades, Eric?
Yeah.
Sarah, I'm gonna talk with Eric. I'm gonna talk with Eric about that right now.
Oh, okay.
So yeah, let me talk to him.
Okay.
All right, and I'll talk to you guys tomorrow. Talk to you tomorrow.
Sounds good.
Cool. Sounds good. Sarah, I'm going to put you in the waiting room. Oh, let's stop. Here, let me stop recording.